Hi, Bob.
Hi, David. How are you?
I'm great. Thanks for joining us again on Tramex Talks. We're glad to have you back.
Well, I'm glad to be here. Thank you.
Today's question, we're looking at the common conception online of the use of a concrete moisture meter being to locate where to put an RH probe.
Using a concrete moisture meter for location of where to put a humidity probe is apples and oranges. A humidity probe only measures the water vapor that's in whatever available airspace there is in concrete. A moisture meter, such as Tramex, measures the moisture content that the RH probe can't see. If you use a concrete meter, such as Tramex, it will tell you exactly how much moisture is in the concrete. That is completely separate and apart from water vapor. Now, if you want to do a comparison on how much water can be in concrete or a concrete pour versus water vapor, the volume difference is huge. Because if you look at a psychrometric chart at the grains per cubic foot, even at 100% relative humidity, that's barely any moisture in the airspace, about 2 to 4%. Now, if we compare that with the volume of water that can occupy the same airspace, I like to use a cubic meter of open space. If you take a cubic meter of open space, it takes 264 gallons of water to fill it. Okay, that's at 100%. Now, if you want 100% relative humidity at 75 degrees, you need less than 2 ounces of water.
Wow.
Now, that's a huge difference. So they do not correlate. If anything, they should use RH probes for the concrete meter because the RH probes cannot tell you what the moisture content is. They can't do it.
So this is why we suggest coupling another test with the relative humidity test. Generally, we see manufacturers currently suggesting a calcium chloride test with a RH test. How do you feel about that compared to a Tramex concrete meter test alongside RH or compared to calcium chloride?
Calcium chloride, if it's done properly, is quite accurate. But the problem is, because you don't know what kind of concrete you're dealing with, you don't know how far to grind into the concrete to get down to raw concrete. So how do you qualify that for a calcium chloride test? Because it is not accurate unless you have full unfettered access to the concrete. Because if it has even a carbonated surface, that's disproportionate amount of water in the carbonated surface than what's immediately under it. So you're dealing with a very inconsistent material, but you're given a consistent approach, which is wrong. You'd have to train somebody on running pH tests, make sure that the pH is at least a 9 before they conduct a calcium chloride test. And that's not being done. At least 90% of them that I have seen have been giving us bad information.
And that as opposed to a non-destructive test with a concrete moisture encounter?
Because that'll give you the total in the gradient portion of the concrete. The gradient portion of the concrete is what contributes to flooring problems. It is not 40% into the concrete where the relative humidity might be higher. So what?
So the top 3/4 is the significant area to be looking at.
Yes, or less. I wouldn't, 3/4 of an inch, if the concrete's really bad or very poorly cured, that's how deep the gradient can go. But that's kind of a maximum. So that's what I like about the Tramex. It reads about 3/4 of an inch into the concrete. So it takes into consideration the average amount of moisture in there. So I really like that.
And it's giving you an actual percentage of moisture content.
Correct. Because concrete originally has 6 to 7% moisture content. Tramex happens to start at that percentage, which is, to me, is perfect. It's designed for concrete.